A cannon.
You don't even know it.
And that's wrong for at least one reason, which is here, which is this is called the Taylor KO factor. Basically, it's a mathematical approach for evaluating the stopping power, which is basically the penetration power of a bullet for hunting cartridges. Let's assume that the pistol that they had in the movie was a .45. According to the Taylor KO factor, if you take the mass of the bullet in grains, 1 pound is about 7,000 grains, and you take the velocity of the bullet in feet per second, and you take the diameter of the bullet. For a .45, it weighs 231.5 grains. It travels at approximately 836.61 feet per second, and it has a diameter of 0.452 feet. If you plug this into the formula for Taylor KO factor, you get about 12.5 Taylor KOs. That's about the same as saying 690 millimeters of penetration power. So basically, after the first head, the bullet's just going to drop straight to the ground. And for comparison, a 50 caliber bullet, which is about yay big compared to a .45, which would probably be like that, has a Taylor KO factor of 147, which is approximately 125 Taylor KO factor bigger than this. And that's Alex. What I wanted is a totally fake movie.
You got me again. What's up, Nick?
What's up,
John? What up, Doc? Alright, Nick.
Yeah.
I know got you heated on two topics, Wanted and V for Vendetta. And like, honestly, I honestly thought Hollywood got me, being stupid, you showed me. But Fast and Furious is real. I'm telling you. Like, this scene is real.
Yeah, I haven't seen it. Which one?
I remember the scene where those two Dodge Chargers pull
oh my god!
That thing.
Oh my god! Yo, that's not real!
Are you kidding me?
Yo,
I can't even do that. Ray, you're doing that. Ray, you're doing
Alright.
Well, the plan's working. You guys have every corrupt cop in Rio on your tail. You guys have to move fast.
What's the best route?
Okay, keep going straight another half mile until Rua Fonseca. And then go left.
Spikes ahead, Don. We got spikes.
We're going right.
Nah, it's too tight. We're not gonna fit.
We got no choice now.
Alright, Ray, show Alex why he's wrong now.
Alright, Alex. To further disprove your beliefs, we've done the math and calculated all of the forces and the friction in the problem. First off, we'll start with the givens. Each car, assuming that they're the maximum output and the best cars of the cars used in the movie, here you have the torque, which is 470 pound-feet, and the horsepower. Then, here we also researched the max towing capacity of the cars, which is 2,000 pounds. Now, considering that the weight of the safe itself is 50 tons, which is 100,000 pounds, right there we have disproven that this is possible. But we took it further. So, the safe weighs 45,359 kilograms. Considering that the back of an 18-wheeler is 5,443 kilograms, you can understand how much this safe weighs. Now, we next moved on to our free body diagram. In the free body diagram here, you see a safe, you see the mg, natural force, and then you see the friction pulling one way and the force of pull pulling the opposite way. So next, we moved to actually calculating the force of friction. So what we did was, we calculated the force of steel on concrete, and we got that the coefficient of friction is 0.45. And when we did the math, we got that the force applied by the friction is actually 200,034 newtons. We then moved on to calculate the force put by each car, or the combined cars, and by using the 0 to 60 times that we researched online, and using the basic formulas that we used in the beginning of the year, we calculated that each car puts out 12,275 newtons, which combined 24,550 newtons, which is actually 1/8 of the friction that is put by the safe and its weight and the coefficient of friction. Therefore, this math proves that the scene is completely impossible. It's also important to take into consideration that the cables would turn and would tangle. And then also, it's important to mention that when we did this problem, we assumed that the tires were some ideal super tire that would not skid at all. So all these units are assuming that the tires have 0 skid.
DJ Steve.
Oh yeah, let's take a trip.